to all of you for coming today and listening to my talk. We're halfway through the conference and we've had a couple of nights already, so it's good to see everybody here. This work is I'm looking at the issue of water sharing within a catchment within the Murray-Darling Basin, and I want to pay tribute to my co-authors there. Ramalan is here, but the rest of them not able to be here, and they are of different disciplines. Well, I'll come to that shortly. And this issue of water sharing between irrigation and the environment, it's an issue worldwide, and we've got population growing, demand for food, and very much environmental concerns associated with that. So how do we look at those issues and with limited water supplies and this demand for food? In Australia, we've got the Water Act of 2007, which actually changed the priority, although there's some debate about legalism of what the Act actually says or what it means. But my reading of it changed the priorities to first, or prioritise the environmental use of water, and then diversions or consumptive uses. And indeed, the guide that came out last year proposed those sustainable diversion limits, and there's going to be a basin plan come out this year or next year. And we've seen already some of the speakers talk about the adverse reaction to these draft sustainable diversion limits. And the question I was really thinking about was this issue of setting or providing information for people to set the diversion limits, or this policy question about diversion limits. And in fact, this work is actually very preliminary. It's we've got together for this paper, and I'm looking for feedback on a way to go forward. And so the question is, what might be these outcomes from alternative diversion limits? What might be the trade-offs? So economists like asking questions about trade-offs, and some of my co-authors aren't economists, and one of the conversations we've had is about getting them to think about this issue, which has been really good. And so some of the things that might bear on that are, will we have our current climate, which is the droughts and flooding rains that you mentioned, or will it be drier in the future? So that's what I call an aggregate water supply issue. And then in this work we're trying to actually have a fairly detailed modelling or assessment of changes or responses on both the agricultural and the environmental side. And we're going to consider different shares of those different aggregate quantities, if you like. And we've also been talking about this different levels of environmental compliance or risk associated with those different quantities of water. And one of the good things has been this conversation between disciplines, if you like. So that's been fun. And the Farms, Rivers and Markets project, which I'm on, is the paraphrase, doing more with less water. It's for a particular catchment, the broken catchment in northeastern Victoria. And so we've got those different disciplines there, and as I said, it's been good to have a talk to them. And it's mainly talking today in this paper about the analytical framework and how we're developing to answer some of those questions. And so the results are preliminary, but I'm looking for feedback about what might be possible. When I first talked to people within the project, I said, okay, well, if we have these couple of different aggregate water supplies, a historical or a dryer, I said, what about if we evaluate these different shares to, say, might be to agriculture and the environment? So loosely talking about sustainable diversion limits and what might be the trade-offs involved in that sort of process. So, and we're sort of stuck, I guess, with the broken catchment, which is in northeastern Victoria, and it's characterised, it's got one major impoundment or dam, which is Lake Nillacoody, and it's not that big. It's the irrigated areas are these little red ones, so well down to the lower reaches, and the irrigation is from the river or the stream channels, not from irrigation channels, if you like. It's also a very small proportion of the land in the catchment is irrigated, so it's a bit atypical in that sense. And in fact, if you look at the quantity diverted compared to the average flow, it's about, I don't know, 16–19%. It's well below actually the STL. So it's not necessarily too much of a policy issue in this catchment, but the Goulburn catchment next door is 79% or something like that. So the SDL for the Goulburn Broken was 25 to 34%. I think that was the diversion limits. That's what they were recommending that consumptive users or agriculture would have to come down to allow enough water to protect the ecological assets in those two catchments. So the issue is maybe slightly different from the Broken to the Goulburn, but we can think creatively about how we can look at those sorts of issues. So the main thing that we've done in the project so far for this paper is think about this conceptual framework that we've tried to use to analyse these questions. So we've got broadly the environmental side here, and the agricultural side here, and we're looking at a river modelling, stream flow modelling process, and to get some information about these trade-offs for different shares. So in general terms, that's what we're trying to do. And I've also got a bit of catchment assessment. I'm not going to talk about that today. On the environmental side, or the ecological side, that top left, the Water Act says to protect, restore and provide for ecological values and ecosystem services. And in the basin, the environmental assets, I call that the overall goal perhaps. In the basin we've got native fish, macroinvertebrates, riverine vegetation and geomorphology. So those are the sorts of assets we're considering in this work in this particular basin. And the ecologists, when I spoke to them about this concept of trade-offs or a response surface, I thought, a production function, water input, fish output, some sort of curve, and that's what I was looking for from them. But they said, no, we'd like to take that definition of what the Act wants, and we'd like to try and achieve that, but maybe we can put some sensitivity around that. So what they did is they went and they had an expert panel, a meeting and some discussions. They developed these 17 objectives or priorities to meet those goals within the catchment for those 4 assets. And so, particularly in terms of geomorphology, the sort of the river characteristics, and so they developed 17. They ranked and prioritised them, and then they said, what about if we meet all 17, or only the top 10, or only the top 5? And so they're still trying to meet that ecological goal in the Act, but we might have it with different risks of achieving those outcomes. And so they were responsive to me a little bit in terms of trade-offs, if you like. And so those levels of river health are associated with probabilities or compliance with achieving them, and maybe with different levels of water use. And so we had this process, the ranking. After we'd specified these, they had an e-flow predictor program that developed the flow regime. So these are the flow regimes coming down into this source river model we'll talk about in a minute. On the environmental agricultural side, we have developed some representative farm linear programming models of irrigated dairy and horticulture so far, and we still want to do irrigated viticulture and dryland. And we just varied these water allocation shares, and we looked at the optimal farm plans associated with the declining levels of water that might be available in our little experimental design. And so we developed some water demands from the agricultural side on a monthly basis from those models. We scaled them up to the catchment level as 2% of the catchment. And so that was the demand for water coming in on the other side. And this shows the sort of area. If we change the water allocation down here, then this is the sort of area within the catchment that might be irrigated, if you like. And so when we have those, we have an associated water demand with each of these different areas, and that provides the input. But I guess the point is that for an irrigated agriculture, as we reduce the water allocations, as we would expect, the area irrigated declines, and income declines as well. But these are short-term responses at this stage. We haven't really looked at whether there could be structural change over longer term. But these are initial associated results that go into the model. And so source rivers, which was that central box in our scoping diagram, and so it's a network river allocation model, and it simulates the river system. It looks at the temporal movement of water through the system. It's a node-link network. It tracks ownership and routes flow. So it's taking the demand from those two different sources and the supply from historical records of rainfall and what comes out of the dam, and puts them together and sees whether the stream flows to meet those objectives can be met and how often, and what's the impacts on water